Cube with edges 1/2 inch long is shown below. What is the length in inches of the diagonal that runs from one corner of the cube to the opposite corner? This problem is not too hard if you understand the Pythagorean theorem. So let me give that to you again real quick in case you don't remember it off the top of your head. Say we have a triangle that's a right triangle, and we can label the sides whatever we want, but it's kind of traditional to call them A, B, and C. And this is a right triangle like so, has a 90-degree angle there. Then there's a relationship that's always true, that the length of A squared plus the length of B squared is equal to the length of C squared. C is kind of special, it's the hypotenuse on opposite from the 90-degree angle. A and B are interchangeable here. All right, so this is a basic fact of geometry that's kind of worth memorizing if you don't have it memorized. There are proofs you could find online for why that's true, but it comes up often enough, I would go ahead and memorize it. So you say, okay, well, Ben, you know, I know this relationship, I understand this, but how can we make this a problem of right triangles? And so let me show you. So here we have this blue line, and I want to point out that if I knew the length of this red line down below it, and I knew the length of this green line here, which I actually do know, it's 1/2, then I would have a right triangle. So let me redraw this here. I would have a right triangle that had a green line with length 1/2, had a red line base with a length that we're not quite sure of, and then had the blue line as its hypotenuse. And this would be a right triangle, and so the relationship would hold that the length, let's see, we'll call the blue, we'll call it, maybe we'll just call it blue. You know, that's what we're trying to find here. So in this case, 1/2 squared, which is kind of the same as saying A, 1/2 squared plus whatever question mark is squared is equal to, sorry, I should have squared like this, is equal to blue squared. All right, so we're one step closer to our goal here, but we still need to figure out, well, what's the length of red? And so it turns out red is decomposed into a right triangle as well, and it's actually one that we know both of the sides to. So here, there's a side to a right triangle down there, and there is another side here. So let me redraw this triangle over here. We can imagine that we have a side here that's 1/2 of an inch, and that we have a side on the base that's also 1/2 of an inch. And then the hypotenuse, the side opposite from the right triangle, which is right here, and which we are calling question mark, is the same as this length. So if we can now find question mark, given the fact that this is also a right triangle. And we know that both of these are right triangles because we know that a cube is composed of 90-degree angles. And so this angle is a 90-degree angle, and also this angle between the green line and the red line there is a 90-degree angle as well. All right, so let's actually go ahead and now it's pretty much an arithmetic kind of algebra problem, but we have 1/2 squared plus 1/2 squared is equal to whatever the length of question mark is squared. And if we do the algebra there, we end up getting, let's see, 1/2 squared is 1/4. So we have 1/4 plus 1/4 is equal to, and I'll just switch, well here, I'll keep switching colors. 1/4 plus 1/4 is equal to the length of question mark squared. And if we go ahead and finish up the math here, 1/4 plus 1/4 is 1/2, 1/2, and we can take the square root of both sides, and then we get that the square root of 1/2 is equal to the length of question mark. All right, so now let's come over here. Since we know the length of question mark, let's substitute it in. This is actually now the square root of 1/2, and then that whole quantity is squared because the question mark is squared there. And now we just have the same operation to do. So let's see, 1/2 squared is 1 over 4. And then let's add to it, let's see, the square of a square root is just the number itself. So the square root of 1/2 squared is simply 1/2. And that is equal to the length of blue squared. All right, so if we add together 1/4 plus 1/2, that's equal to 3/4. And if we take the square root of that, we will have the length of blue, which is the square root of 3/4. And the answer is, oh wait, we're not quite there yet. There's a way to simplify this. And so we can actually rewrite this as the square root of 3 divided by the square root of 4. And you may know the square root of 3 we can't find. That's just going to remain the square root of 3. But the square root of 4 can be found. It's 2. And if you didn't know that, you could have also plugged these values into the calculator and realized that the correct answer is E. Figure below, angle ABC is the same angle as angle DFE. So from A to B to C, that's this angle right here. From D to F to E, that's this angle right here, and they have the same measure. They also say that angle BAC is equal to angle FDE. So here from B to A to C is this angle, and it's equal to the angle from F to D to E, this angle right here. D and F are on AB. Okay, that's pretty obvious looking at the graph. The line segment AD, that's this guy right here, is the same length as the line segment FB. All right, that's an important clue too. And the distances are as shown. What is the length of AD in centimeters? All right, so what we can, there's two parts to this problem. And the first part is that we can figure out this length from B to A. And if we know the length from B to A, then we can also figure out the length from of AD, because that's just equal to this number 6, which is F to D here, plus 2 of these little red line segments. So 2 times the distance AD. I also could have written plus AD plus FB, but they're the same length, so we can just write 2 times AD. Now all we have to do is figure out B to A. So what's that line segment B to A? Well, the trick to this is to realize that what we have here are actually 2 triangles that are the exact, one is just a shrunken copy of the other. So this triangle from F to E to D and back to F again is the exact same shape as this bigger triangle. And we know that because it has the same angles. These angles they've told us are the same. We can actually calculate that these remaining angles are the same. So if we were to make this triangle, if we were to just imagine expanding it, it would expand to the same size. And that tells us a very important thing. That tells us that it was shrunken, 20 was shrunken down to 12 here. So this 20 was shrunken down to 12. And then we know that whatever AB was, so this line segment, or as I was calling it BA before, is shrunken down to 6. And that allows us to establish this relationship that BA is equal to this. So now we can just solve for BA. Let's go ahead and multiply both sides by 6 here. So this 6 cancels out. This becomes a 2, so we have 20 over 2 is equal to BA. And this just simplifies to 10. That's what's equal to BA. And now we can use this relationship that we established before to go ahead and solve for AD. So here, where we have BA, let's just set that equal to 10. And now let's subtract 6 from both sides. So 6 minus 6 there will just be a 6. Over here it's a 4. So 4 is equal to 2 times the length of the line segment AD. And let's go ahead and divide both sides by 2. The line segment AD is equal to a length of 2. The answer is D. So, the big day of your ACT exam is coming up tomorrow. What kind of things can you do at the last minute to improve your score as much as possible? And the first piece of advice that I'll give you, which might not seem obvious, is to stop studying. You might be tempted to study right until the last minute, but if you do that, then you're going to be stressing yourself out, you're not going to get enough sleep, and you're really not going to be able to learn enough in just one evening to significantly change your score. Much better to stop being stressed out. Give them maybe an hour to study, review some basic facts, and then stop. Also, related to this, get some sleep. You want your brain working at 100%, and it's only going to do that if you're not tired. Similarly, eat some food. This is a good dinner, a good breakfast beforehand. Again, getting your brain up to 100%. And finally, this is a big exam. It's likely that before you go into it, you'll start feeling stressed out and anxious. And that's okay, because it's good. It's pumping your brain up to be anxious before an exam. I say own it. Own your anxiety, realize you're going to get a little nervous, feel that anxiety welling up within you, and use it to give yourself focus on the exam and to just work as hard as possible. So thank you so much for taking this course. I hope it's helped out. I wish you guys the best of luck on your exam, and please share your scores with me. Let me know if you have any success stories. I'd love to hear them. It's the reason I'm doing this.